If you are heading into Senior DevOps or Platform Engineering interview in 2026, they are not going to ask you what a provider is. They are going to ask you how you handle a production outage caused by a corrupted state file, or how you manage 5,000 plus cloud accounts without hitting API rate limits. Most candidates fail because they give textbook answers. Today, I'm giving you the real world answers. We are debugging advanced Terraform scenarios that I have personally faced in my AWS project and actual interviews. These are the questions that separate the junior devs from the experts who actually get the offer. Thank you everyone for all your support so far. If you want to level up your cloud game, hit that subscribe button right now. Let's get into question number 1. So, the first question is, you have a massive main.tf and you need to move resources into a module without Terraform trying to destroy and recreate the actual infrastructure. The answer is not just copy paste. The answer is refactoring with move blocks. In 2026, we don't manually run Terraform state MV anymore. That's risky and hard to track in CI/CD. Instead, you use the move block directly in your code. This tells Terraform, hey, this resource used to be at address A, but now it lives in module B. It's a declarative, it's version control, and most importantly, it results in zero downtime. If you mention move blocks in an interview, you already won the room. Now next question. Terraform state files store sensitive data in plain text. How do you prevent a security breach? First, admit the truth. Terraform state file will have secrets. The solution is not just sensitive equals to true. That only hides it from CLI output, not the file. The senior level answer is a 3-level defense. First, encryption at rest. Use an S3 backend with AES 256 encryption and a restricted KMS key. Second, short-lived credentials. For this, you can use a Vault provider or AWS Secrets Manager to generate dynamic, time-bound secrets so the state file does not store permanent passwords. Third, RBAC. Treat your state bucket like a nuclear silo. Only the CI/CD service principal should have access, never individual developers. Scenario 3. Your company is moving from 2 environments to 50. Do you use Terraform workspaces or a directory-based structure? In an enterprise environment, the answer is almost always directory-based structure or a tool like TerraGrunt. While workspaces are great for quick testing, they use the same backend configuration. For 50 environments, that's a blast radius nightmare. If you mess up the state in workspace, you risk the others. The senior approach to use separate directories for each environment with their own backends. This allows you to have different versions of modules in dev versus prod and provide hard isolation. Mentioning blast radius and state isolation shows the interviewer you think like an architect, not just a coder. Let's move to next question. A developer ran an update and now the production CI/CD pipeline is failing because of a breaking change in the AWS provider. How do you prevent this? This is a governance question. The solution is the dependency log file. Many juniors think pinning the version in the code is enough, but the log file is what ensures every teammate and every CI runner is using the exact same provider checksum. In 2026, the expert move is to include the log file in your pull request reviews. If the log file changes, it's a red flag that must be investigated. You treat your infrastructure dependencies with the same rigor as your applications, package.json or requirements.txt. Now, Terraform says 10 resources will be created, but Terraform apply fails halfway through. Now your infrastructure is in a partially created state. How do you recover? This is where you talk about atomic transactions or lack of them in cloud APIs. When an apply fails, Terraform saves the state of whatever did succeed. To fix this, you don't just keep hitting apply. You first check the state to see what's tainted. In modern Terraform, we use the -refresh -only plan to sync the state with reality without making changes. Once you identified the orphan resources, you either fix the underlying cloud issue or manually import the half-created resources so Terraform can manage it. It's all about staying calm and using the state file as a source of truth. Advanced Terraform is not about memorizing commands. It's about managing risk and scale. If you can explain why you chose one structure over another, you are already in the top 5% of candidates. If these 5 scenarios helped you, give the video a like, subscribe to my channel for more such videos, and don't forget to check out my AZ900 roadmap if you missed it. I will see you in the next one.